Welcome to aminacademy.com. In modern physics, let us discuss about time dilation. A moving clock ticks more slowly than a clock at rest. We will discuss about time dilation little detail. In the theory of special relativity, the slowing down of a clock as determined by an observer who is in relative motion with respect to the clock. In special relativity, an observer in inertial, that is non-accelerating motion, has a well-defined means of determining which events occur simultaneously with a given event. A second inertial observer who is in relative motion with respect to the first, however, will disagree with the first observer regarding which events are simultaneous. With that given event, neither observer is wrong in this determination. Rather, their disagreement merely reflect the fact that simultaneity is an observer-dependent notion in special relativity. Here, measurement of time intervals are affected by relative motion between an observer and what is observed. As a result, a clock that moves with respect to an observer ticks more slowly than it does without such motion. And all processes, including those of life, occur more slowly to an observer when they take place in a different inertial frame. If someone is moving spacecraft finds that the time interval between two events in the spacecraft is t0, we on the ground would find that the same interval has the longer time t. The quantity t0, which is determined by events that occur at the someplace in an observer's frame of reference, is called a proper time of the interval between the events. When witnessed from the ground, the events that mark the beginning and end of the time interval occur at different places, and in consequence the duration of the interval appears longer than the proper time. This effect is called time dilation. That means dilate is to become larger. Here, look at this. A closely related phenomenon predicted by special relativity is the so-called twin paradox. Suppose one of two twins carrying a clock departs on a rocket ship from the other twin. That means one is moving in the rocket with high speed, second is stay in the home or stay in some reference frame. An inertial observer at a certain time, and they rejoin at the time later. After sometimes they rejoin together. In accordance with the time dilation effect, the elapsed time on the clock of the twin on the rocket ship will be smaller than that of the inertial observer twin. That means the non-inertial twin will have aged less than the inertial observer twin when they rejoin. That means who are moving faster and come back and meet their twin, that who is moving fast having less age than who is stay in the earth. That means moving faster, while moving faster the clocks slow down. Further detail, look at here. Here, look at this figure. The astronaut, suppose look at this for time difference is delta t0, like a light source is passing to the mirror and come back to the receiver, and the distance is d. Now, look at this second figure. That here the beginning event, this end event, that L is v delta t by 2 because going and come back returning, that is L is v dt by 2, and here this L here. Now look at here, this L is L0, you can use it, v dt by 2, this another L, here this is a S equal to square root of d square plus L square here. Now this is a thought experiment demonstrating the effect of special relativity. Now we will discuss further about this features. Let the proper time is t0, the time needed for the light pulse to travel between the mirrors at the speed of light is c equal to t0 by 2. The t0 is normal time by 2. Hence t0 is 2L0 by c because length by speed is time. Squaring both sides, that is ct square by 2 whole square, that is c equal to that, see here this one, s equal to here, that is ct square by 2 whole square, that is a square equal to L0 square plus vt by 2 whole square. Now opening the brackets, that means squaring both sides here. Here c t square by 4 and here c square, and this side is L square plus v square t square by 4. Then collecting that common factor is t square by 4 we took out, and c square minus v square equal to L0 square. From this we are by cross multiplying we will get t square equal to 4L0 square over c square by v square. That is by cross multiplying, right? Here then 4L0 square we can write is 2L0 whole square by here c square, and suppose c square taken out is 1 minus v square by c square here. Then from this we can get t by using square root. The square root means here 2L0 square by c because the square root, and this is here square root. Therefore t equal 2L0 by c over 1 minus v square by c square, but 2L0 over c equal to t0 initial time. Then there is a proper time in the earth not moving, that here the body is not moving. Look at the reference frame, his time is t0. Now time dilation is t0 over square root of 1 minus v square by c square. This is the important formula for time dilation, and for that t0 is a time interval on clocks at the rest relative to an observer, that is a proper time. Then t0 is time interval on clock in motion relative to an observer. Here not t0, it's a t. Then v equals speed of relative motion, and c equal to speed of light. Therefore t equal, this is a formula, but therefore that is time dilation is t equal t0 by square root of 1 minus v square by c square. Like that, here length contraction also we can find by using this relation, and further details we will discuss in future videos. If you have done, please subscribe our YouTube channel.